Hello friends, welcome back to my YouTube channel. And in this session, we will discuss the previous Uttar Pradesh Power Corporation Limited Assistant Engineer Trainee Electrical paper, so which is held on this month 4th 11 2019. So it's a recent paper. It is held in the afternoon session. The test time is from 2:30 p.m. to 5:30 p.m. So let's start the first question here. In this technical session, a signal x of t with respect to time is sketched as under here. Okay, so it's a given sketch here. The x of t could be classified as, so x of t can be classified as, this is a exponentially rising function. So exponentially rising function means it will have a e power at signal. Okay, exponentially rising signal like this. Okay, so it is exponentially rising. It is a multiplied with some sine omega t function. So it is why normally sine means it is like this sine function. Exponentially rising means it is like this. So if we are multiplying these two, it will be equivalent to it is something like this. So exponentially rising function. Okay, so next we'll go to the next question. Now here the question is a PMMC. Okay, it's not moving. Okay, so let's make some adjustment here to the visibility. Right now, a PMMC instrument. So PMMC instrument which takes 10 milliamperes at 500 millivolts potential difference maximum. How much resistance is to connect across the instrument such that the instrument can measure 0 to 10 amperes current. So here we need to increase the current. So we need to increase the current means I will use shunt resistance. RS is equal to Rm into M minus 1. What is M is nothing but, so maximum value of current divided by meter current. So maximum value of current is 10 divided by meter current is how much? It is 10 milliamperes. So 10 into 10 power minus 3. So 10 is going cancelling here. It is going to be 1000 here. So 1000. Now, so here next one, what we need to find? Rm, meter resistance. So meter resistance Rm is equal to, it is Vm by Im, meter current. So what is a Vm? So meter voltage is 50 into 10 power minus 3 divided by current is 10 into 10 power minus 3. So these two gets cancelled. It is going to be meter resistance is 5 ohms here. Now substituting this formula in this case here, RSH is equal to meter resistance is 5 and M is 1000 minus 1. Okay, mistake here. It is Rm by M minus 1. Okay, make a correction. Rm by M minus 1. So it is 5 divided by 1000 minus 1. So approximately if we take 5 divided by 1000, it is going to be 0.005 ohms. So friends, make a correction here. RS is equal to Rm by M minus 1. For suppose a series resistance means RS is equal to, so voltage multiplier means Rm into M minus 1. So please make a correction here. Okay, so next question. So answer is 0.005 ohms. We'll go to the next question here. Now the eddy current losses in a magnetic core subjected to time varying flux. So it is given by Steinmann's equation. We is proportional to B max square into F square. Suppose if they ask hysteresis losses is proportional to B max to the power of 1.6 into F. So from this conclusion is eddy current loss is proportional to frequency square. Hysteresis loss is proportional to frequency. So one is a right option for this answer. Next one, the power absorbed by the generalized circuit if V is equal to 10 volts. Where is the V? So this is a V. So this V is equal to 10 volts given. Now, so remember this point. So power absorbed or delivered by source. Remember source here. Our source or EMF is always negative. Now it is a source. It acting as a source here. The source means current entering from the positive terminal. As per the sign convention, the current leaving this node. So power delivered or absorbed. So power delivered by source is equal to total. We will keep a minus sign here. Minus of what is the voltage? 10. Current is 8.5. So it is 85 and this is a minus sign, so minus 85 watts. So answer is here it is, answer is B is the right answer for this question. So we'll go to next question here. Now this is from power system. A thermal station has 85% boiler efficiency. What is the boiler efficiency? Efficiency of boiler is equal to 85 divided by 100. Okay, 90% of turbine efficiency. So efficiency of turbine is equal to 90 by 100.9. And load factor. So load factor is nothing but already you know average demand by maximum demand, which is nothing but 0.4, or I can say 40 divided by 100. Determine thermal efficiency of the station. So thermal efficiency of the station is equal to efficiency of the boiler multiplied with efficiency of the turbine into efficiency of alternator. So here the efficiency of alternator mentioned. Assume that efficiency of alternator is 100%. Okay, why? Because with the use of load factor we cannot find the efficiency of alternator. Okay, now it is equal to efficiency of the boiler is 85 divided by 100 into efficiency of turbine is 90 divided by 100. We want to represent in 100 means 100 by alternator means 100 by 100 into efficiency is into 100%. So 100 gets cancelled, 100 gets cancelled. So 85 into 90 divided by 100. So it will be around 76.5%. Efficiency is going to be 76.5 is the answer, right answer for this question. So we'll go to the next question. Next, which of the following errors occur in only in AC instruments? So what are the errors that occurs? That is errors due to change in impedance of the coil. So change in impedance because it is due to change in frequency. Okay, so change in frequency, because of that frequency XL is nothing but 2 pi f into L. So where the frequency changes, automatically inductance value will change, and change in the magnitude of the eddy currents. Okay, eddy currents are because of there is a rate of change of voltage. Okay, so answer is errors due to change in impedance of the coil. Okay, so these are right option. Next one. Yeah, yes. So a moving coil instrument has a coil resistance of 10 ohms. It can take maximum current of 100 milliamperes. What is the modifications required in the instrument to measure a voltage, measure the voltage in the range 0 to 500 volts? So here we need to increase the range of the instrument. So Rm is equal to, sorry, Rs is equal to M into, okay, let's make a correction here. So Rs is equal to Rm into M minus 1. Now what is the meter resistance? It is 10 ohms is given. We need to find M. So M is nothing but maximum voltage divided by minimum voltage. So maximum voltage how much here? 500 volts divided by. Now here we need to find the meter voltage. So it is a 10 into, so 10 ohms into how much current? 100 into 10 power minus 3. Okay, now this 10 will go. Okay, so now 5, so 5 divided by, so 10 power minus 2, so it's going to be 500. Okay, now answer is going to be 500 here. Okay, after this 500 we'll substitute here. So M value is 500 minus 1, so it is nothing but 499 into 100. Okay, so 499 into 100 means we can represent it as 4.99 kilo ohms. Okay, so the answer here it is B is a right option for this answer. So B is equal to 4.99 kilo ohms is the right answer. Next, we'll move to the next question here. So this question is from the control system. The transfer function Vc of S by V of S for the circuit is shown figure. So it is directly you can substitute, directly you can get the answer. It is 1 divided by S square into LC plus S into RC plus 1. Okay, you can compare this. We can compare this equation with the standard equation in control system. Omega n square divided by S square plus 2 zeta omega n plus omega n square. So you can substitute, you will get the same answer here. Okay, if you have any doubt, you can comment. I'll explain it in the next coming sessions, right? Next question. Now find the power delivered by the source with the following circuit here. Okay, so as we see, we'll apply KVL in this loop. First, if you are applying KVL in this loop, minus 20, I'll start from here, plus minus and plus minus plus minus plus minus here. So minus 20 plus 1 into I plus 50 plus 2 into I is equal to 0. Now I is equal to how much here? It is going to be 3I is equal to minus 30 by 3 is equal to minus 10 amperes is the current flowing. As we know, the current is flowing in this direction. The source is going to deliver the negative power. So power delivered by source is equal to, we'll put a minus sign first, minus of current is minus 10 into and voltage is 200 here. So 20 is nothing but 200 watts. So this is given by the source. Now for this source we'll take, so power delivered by second source is equal to minus of, now here the current entering at the positive element, is it act as a passive element or active element? So it acts as a passive element. So again we'll put a minus sign here. Okay, minus of into minus 10 into how much voltage here? 50. Now here it is going to be minus into minus plus, so it is minus 500 watts. So answer here it is PA is the right answer. So next we'll see the next question here. The number of parallel paths in the armature of a duplex lap wound. Duplex lap wound means, duplex means it is a 2. Okay, duplex lap wound 4-pole DC machine is, so number of poles are, it is a 4. Now here what is the number of parallel paths? A is nothing but number of parallel paths equal to M into number of poles P. So where M is nothing but simplex means it's 1, duplex means going to be 2. So A is equal to 2 into number of parallel paths are 4. So number of poles are 4. It is going to be 8. Okay. So answer here it is 8. So that's it for this session. We'll continue this lecture series in the upcoming session. If you like my video, please subscribe, share and comment. So based on your subscriptions and based on your views only, we will get a motivation to do more and more videos. Thank you friends. Have a nice day.